today's topic is the chain rule. This corresponds to section 3.4 in the textbook. So the chain rule, again, a way for you to take the derivative of more functions than you were able to before. So more complicated functions, and really specifically composite functions. So for example, could look at y equals x squared plus 1, so you know how to do the derivative of that. But the chain rule will allow you to do the square root of x squared plus 1. So that quadratic inside of a radical function. Y equals sine x, you know how to do that. The derivative is cosine x. But if you had anything other than 1x plugged in, so sine of 6x, for example, sine of 7x, cosine of 2x squared, the chain rule allows you to do the derivative of that. You could have done the derivative of 3x plus 2. Now, the quantity, 3x plus 2 to the fifth. So a linear raised to a fifth power. So the chain rule allows you to do that. Like before, in the green highlighted, we have x plus tangent x. But if you had x plus tangent of x squared, so a quadratic plugged into a trig function. So the chain rule, by definition, dy dx is dy du times du dx. So there's a new u function, okay? So there's our dy dx notation with du, dy, and dx. What I prefer is this second line right here. Let me bring this down. So the second line, how I see this, I've tried to break it down and identify every part. So let's start with the f. So the f, you could denote that as the outside function. But I'll be upfront, a lot of times when talking about these functions, I will say the overall instead of the outside. So you can think of that as overall, big picture, what's happening in this function. Remember, composite functions are a function plugged into another function. So there's something inside and there's something outside, or overall. G of x, what is plugged into f? Of course, is the inside. So when doing a chain rule problem, you have to identify your outside, your overall, and then what is plugged in, so the inside. The derivative then, let's see if I can zoom in more. We have this f prime, which is that's the derivative of the outside. So outside is f, derivative of the outside is f prime. And then you do f prime, and then g, just leave the inside alone. So f prime, derivative of outside, g, leaves the inside alone. And then lastly, you then take what you have, f prime of g, and now of that, you multiply that. By the derivative Okay, so Loom cut me off, had to upgrade. Hopefully it'll be a seamless paste from the previous video to this one, but my editing skills are bad, so we'll see. So to pick up where we left off, you multiply by the derivative of the inside. So you gotta first identify an outside or an overall and an inside. So then derivative of the outside, do the overall rule. The inside, leave it alone. Don't change it. Then once you've done the outside, you then multiply everything by the derivative of the inside. So let's see how that works in practice. So across of these, don't need them. We're going to do a couple examples to kind of see how this works. So this 1 over x plus 1, it kind of helps sometimes to do a rewrite. That x plus 1 at the bottom, move it all up to the top, give it a negative exponent. So x plus 1 in the top, it was to the first, so in the top is to the negative first. So then identify the outside and the inside. And it can be easier sometimes to identify the inside first. So inside, think usually inside parentheses, inside the radical function, inside the square root symbol. Inside absolute value, so kind of what is tucked into the problem, okay? So this x plus 1 is inside the parentheses, so that's our inside function. To the power of negative 1, that would be our outside, or overall what is happening in the problem. So when you go to take the derivative of this, do the derivative of the inside, derivative of the outside first. So outside is all to the power of negative 1. So bring that negative 1 down. And power of rule, decrease the exponent by 1. So now negative 1, decrease by 1. Now to the negative 2. Then leave the inside alone. So x plus 1. Okay, so derivative of the outside. Oh, sorry, wrong tool. Highlighter to derivative of the outside. So the negative 1 came down. Decrease exponent by negative 1. Then leave the inside alone. Then we're going to multiply by the derivative of the inside. So derivative of x plus 1 is just 1. So to simplify this down a little, the negative 1 at the front, just negative, quantity x plus 1 to the negative 2, times 1, don't really need that. So if we wanted to algebraically manipulate this for a multiple choice problem, y prime is negative 1 over quantity x plus 1 squared. Kind of either one works. Alright, so kind of seeing that process, how it works, let's look at another one. So y equals sine of 2x. So sine of 2x. Remember, composite functions are f of g of x. So f of sine of 2x. So 2x is our inside. Kind of think of this sine 2x as being sine parentheses 2x. So then the sine overall what's happening, that is our outside function. So let's go ahead and evaluate this using the chain rule. Y prime is derivative of the outside, so derivative of sine is cosine. Then leave the inside alone. So we have derivative of the outside, and then we leave the inside alone. Lastly, you times by the derivative of the inside, so derivative of 2x is 2. So to really basically clean that up, 2 cosine of 2x. There you go. Let's look at another one. For the radical, it might help to rewrite it like we've been doing. So y equals quantity 3x squared minus x plus 1 all to the power of 1/2. So now you see we have, just like we had the radical, now we have the parentheses, we have a quadratic plugged into a radical function. So we have our inside, and we have the 1/2 power, or the square root, as the outside. So derivative of the outside, the 1/2 power, bring the 1/2 down, decrease 1/2 by 1, so 1/2 minus 1, negative 1/2, and leave the inside alone. And then multiply by the derivative of the inside. So 3x squared minus x would be 6x minus 1. And if there's a F or Q, or really nice multiple choice, leave it alone, there you are. If you have to algebraically manipulate it, okay, the quantity 3x squared minus x plus 1 to the negative 1/2, put that in the bottom, make it square root, and the 2 of the 1/2 goes with it. So 2 root 3x squared minus x plus 1, and the 6x minus 1 goes in the top. So some algebraic manipulation of that problem, okay? Down at the bottom, example D, the tangent squared x. Another way to write that, just to clear this up, is y equals, we have tangent squared of x. So tangent of x is being squared. So you can rewrite that if you want to see that way. Go ahead, take a look at the rest of the examples. Check your answers with my completed notes. One thing I'd like to say before I stop is that this cube root you can rewrite as y equals quantity x squared minus 1. The index becomes a denominator of a fractional exponent. The power becomes a numerator. So quantity x squared minus 1 to the 2/3. Then you can evaluate that, just like you have all the others.